Hi folks, this is Karim Raouf from our Visualizer channel. We will continue our Lab Matrix Labs, the video number 46. We have been discussing in the previous video the following. We have still working on the findings of the test report concerning our primary domain controller. We have seen a lot of findings, how these findings are solved, and also we have seen a lot of successful tests done on our primary domain controller by the Testomo report. We have discussed the successful points and the failure points. So today we will continue working on a finding called LAN-MAN server. We have successfully passed this test. What is the LAN-MAN server? It is basically talking about the SMB protocol, which is very critical for file and print sharing. It is discussing about some of the configuration of the SMB protocol. Okay, so we need to tweak it a little bit. First of all, we need to enable security signature and require security signature. We enable SMB security signature, which is very critical for securing the connection between the user and the connection to the shared folder on the file server. This is very critical to enable security signature, which is basically I think it is maybe encrypting. Okay, this is the one thing we need to see. We have a couple of things here, or a couple of recommendations. Enable security signature and require security signature. This is from the server side. We need to digitally sign communication. So I think this is encrypting the connection between the client and the server. And this is you should sign the connection if the client agrees, because sometimes some clients doesn't have the necessary tools to encrypt the connection between it and the server. So you need to have the tools necessary for the encryption from the server side and the client side. So here we are saying digitally sign communications if the client agrees. And here another thing called required security signature, digitally sign communication always. So there is two things to enable security: if the client agrees, and to always sign the connection, or sign or always sign or secure the connection. But I think this should be from both sides. So let's see first what is the LAN-MAN server. Here the LAN-MAN server in specific, what it is. It is a known simply, or this is a service in Windows called LAN-MAN server. Okay, it's a crucial component in Windows operating system. So this is a service in the Windows called LAN-MAN server, and you can simply say it as server. Okay, or a simple term or simple short name is server. Okay, it is a crucial component in Windows operating system that facilitates file and print sharing over a network. It allows your computer to share resources as files and printers with other devices on the same network. By default, the service is set to start automatically when the operating system boots. Okay, so this is it running under the local system account. This is the system account in Windows within the service host process, okay, along with other services. Okay, so this is basically what is the LAN-MAN server. If we go to ChatGPT 4o, it is saying the same. It is a service in Windows called server, provides the file and print sharing services over the network. It allows your computer to share resources as file printers and name pipelines and other computers on the network. The service is essential for networked environments where Windows-based systems need to interact with each other or devices using the server message protocol. Okay, so this is the LAN-MAN server. It is used for file print sharing, and named pipelines. What is named pipelines? Supports inter-process communication, IPC, by allowing programs running on the different computers to exchange information. So also it is used by the server to exchange data with programs on other devices, okay, or other servers or other workstations. I think here is referring to this one. Okay, so this is the LAN-MAN server, and if we see here the test, it's here. This is a service, and also it had registry keys. If we go there and see the registry keys, we will see a couple of things. Here, for example, one of the things that the test sees is to enable forced logoff. What is enable forced logoff? You should log off the user from the file server after the login hours is expired. So for example, if you have set the computers to work for a certain login hours duration, for example, if you have set the login hours, for example, for 10 hours, okay, if the user left the machine, okay, and the connection to the file server is still there, okay, and the login hours have expired, it will disconnect the user from the share. Okay, so let's see what is enable force logoff. We will see this, the Department of Defense have discussed this issue, and we can see here enable security signature and require security signature. We will discuss all of these, okay, one by one. But first of all, we need to see the test here to enable force logoff. If we go and see the Department of Defense explanation concerning this thing, users should not be permitted to remain logged on the network after they have exceeded their permitted login hours. Okay, maybe 10 hours, maybe the thing you define in the Active Directory. We all know that you can go to the computer object in the Active Directory and set some login hours for the users. Okay, or I think not from the computer side, from the user side, you can set the login hours for the user. For example, maybe from 8 a.m. to 5 p.m. and so you can restrict some login hours on the machines. Okay, in many cases this indicates the user forgot to log off before leaving for the day. However, it is also indicate that the user is attempting unauthorized access at a time when the system may be less closely monitored. Okay, so this may be a hacker. Okay, forcibly disconnecting users when login hours expire protects critical and sensitive network data from exposure to unauthorized personnel with physical access to the computer. So this can be done from the registry key. Here we can see enable forced logoff, and we can see here is the value, it is 1, and we can do this from as we can see here from the security options group policy, disconnect the client when log off hours expired or login hours expired. Okay, this is enabled. Okay, so this is one thing we need to do this from the registry or using a group policy. And we need to enable security signature. This is to secure the communication between the client and the server, maybe file server, maybe share. Okay, or it's basically for the shared folders, and basically it is on a file server or maybe on a domain controller. If you have the sysvol folder or the netlogin folder, this is our shared folders. So you should secure the communication between these shared folders on the domain controller. And by the way, I think all of the communication between the domain controllers and the clients are secure and signed. Anyway, so we can see here also another recommendation by the Department of Defense, enable security signature. If we go there, the server message block protocol provides the basis for many network operations. Digitally signing SMB packets aid in preventing man-in-the-middle attacks. If this policy is enabled, the SMB server will negotiate SMB packet signing as requested by the client. Okay, so this is basically you can sign or the packets will be signed and sent between the client and the server if the client accepts. We can see here that enable security signature, this is 1, and we can see here that in our registry it is 1. So enable security signature and require security signature will secure the communication between the client and the file server, or between the client and the shared folders on maybe the domain controller, or maybe on the file server. So this is basically one thing to secure the communication between the clients and the shared folders on the servers. Okay, so this is basically one thing we need to focus on. Okay, if we go there and see, for example, so here we need to enable these two, and we have it already. We have these two enabled, by the way. So here the test is making sure that users are logged off after the login hours expire, and the communication between the client and the server to the shared folders is secured by enable security signature or require security signature. Okay, and this is done from the server side. Okay, and we can see here how some of the URLs discussing how we can enable this or why we should do digitally signed communications. Okay, if we go and ask or if we see these registry keys, okay, if we ask Perplexity to explain these registry keys concerning the SMB protocol, we have already three of them explained. Enable force logoff, we have already known what it is exactly, and require security signature and enable security signature. The rest can be explained by Perplexity if we go there and ask it to explain it. Let's go and see there. So here, this is the explanation of the registry keys. Let's see or read them loudly.
The Lamont server service in Windows has several registry keys that control its behavior and security settings. Below is an explanation of the specific registry keys you mentioned. Registry keys explained. Auto disconnect. This setting specifies the duration of inactivity in minutes, after which a network connection will be automatically disconnected. The default value is typically set to 15 minutes. Setting this to a lower value can help manage resources, but may inconvenience users who expect persistent connections. Enable authenticate user sharing. When enabled, this setting allows authenticated users to access shared resources. When set to true, it enforces that users must authenticate before accessing shared files or printers, enhancing security by preventing unauthorized access. Enable forced logoff. This key determines whether users are forcibly logged off when they exceed their allowed session time. Setting this to 1 enforces logoff, while 0 allows users to remain logged in indefinitely until they manually log off. Enable security signature. This key, when set to 1, enables SMB signing for the server, which helps secure data in transit by ensuring that messages are not tampered with. If set to 0, SMB signing is disabled, potentially exposing the server to man-in-the-middle attacks. GUID. This key typically contains a globally unique identifier associated with the server service. It is used for various internal operations and can help in identifying the service instance. Null session pipes. This registry key lists named pipes that can be accessed without authentication, null session access. It is a security risk if not managed properly, as it can allow unauthorized users to access sensitive data. Administrators can restrict access by modifying this list. Require security signature. When set to 1, this key requires that all SMB communications to and from the server are signed. This is a critical security feature that helps prevent data interception and tampering. If set to 0, signing is not required, which may expose the server to vulnerabilities. Restrict null access. This setting, when enabled, set to 1, restricts access to named pipes and shares for null sessions. This is an important security measure to prevent unauthorized access to resources by anonymous users. Service DLL. This key specifies the path to the Dynamic Link Library, DLL, that the Lamont server service uses. It is crucial for the operation of the service, as it contains the code that implements the server's functionality. Service DLL unload on stop. This setting determines whether the DLL specified in the service DLL key should be unloaded when the service is stopped. If set to 1, the DLL will be unloaded, freeing up resources. If set to 0, the DLL remains loaded, which may be useful for performance reasons but could lead to resource leaks if not managed properly. Summary. These registry keys play a significant role in configuring the security, performance, and behavior of the Lamont server service in Windows. Proper management of these settings is essential for maintaining a secure and efficient network environment. Adjusting them can enhance security but may also impact usability, so changes should be made with careful consideration of the network's requirements and user needs.
So this is the explanation of these registry keys. If you can see here, we have already auto disconnect for 15 minutes to disconnect the users to the shared folders or printer shares if they didn't do any activity for 15 minutes. Enable authenticate user sharing. Here it is disabled. So that means that sharing, we don't need to provide a username and the password to access a shared folder. Okay, so this is not enabled. Enable force logoff, we have seen this one. This is one. Enable security signature, this is one. This is the GeoID. Null session pipes, as we can see here, require security signature. We have seen this. Restrict null access, okay, or null session access. This is one on one. And we can see that the most important registry keys is enable force logoff, enable security signature, and require security signature. Okay, so let's see how ChatGPT will explain these registry keys. If we go there and tell it to explain in simple terms, let's see what will be the answer or how we will explain it.
Certainly. Here's a simplified explanation of the LAN/MAN server registry keys you mentioned. 1. Auto disconnect. What it does. This setting controls how long a network session remains connected after it becomes inactive. Simple terms. If someone connects to your shared files or printer but stops using them for a while, this setting decides how long to keep that connection alive before automatically disconnecting it. 2. Enable authenticate user sharing. What it does. This controls whether user authentication is required for accessing shared resources. Simple terms. It decides whether users need to log in with a username and password before they can access shared files or printers on your computer. What it does. This setting forces users to be logged off when their session expires. If someone is using shared resources on your computer and their access time runs out, this setting makes sure they get kicked off automatically. 4. Enable security signature. What it does, this setting enables or disables the use of digital signatures for securing communications. Simple terms. It helps ensure that the data being shared between computers hasn't been tampered with by requiring an extra layer of security, a digital signature. 5. What it does, this is a unique identifier for the LAN/MAN server service. Simple terms. Think of it as a unique ID card that identifies this service on your computer. NAR 6, null session pipes. Lists the names of pipes, channels that can be accessed without requiring a login. Simple terms. These are special pathways that certain programs can use to communicate with your computer without needing a username and password. 7. Require signature. What it does. This forces the server to require security signatures on all network communications. Simple terms. It makes sure that every piece of data shared over the network is signed, adding an extra layer of security to prevent tampering. What it does. What it does controls access to shared resources by null sessions, sessions where the user hasn't logged in. It decides whether someone can access your shared files or printers without logging in. 9. Service DLL. What it does points to the DLL dynamic link library file that contains the code for the LAN/MAN server service. Simple terms, it's the file that runs the LAN/MAN server service on your computer. 10. Service DL unload on stop. What it does determines whether the DLL mentioned above is unloaded when the service stops. Simple terms, it decides whether the code for the LAN/MAN server should be removed from memory when you stop the service. These registry keys control various aspects of how the LAN/MAN server service functions on your computer, such as security, connections, and resource access. Modifying these settings can change how your computer handles network sharing, so it's important to understand their impact before making any changes.
So as we can see here, this is the answer of ChatGPT 4o. As we can see here for Claude, okay, here all of the AIs are saying enable force logoff. This when your session time expire. This is not correct. This is when your login hours expire. So here they are giving a wrong answer because they thought it is related to the session time, not the login hours time. Okay, so this is one thing to note. Okay, so not all of the AI answers are 100% correct, but just to help us to explain some of the concepts. Okay, so here we can see we have the test. We have already we should enable forced logoff. We have already done this, or it is already by default. or it is enabled by a group policy, and we have enabled security signature, and we have the required security signature. So let's see how this is done in practical terms, and then we will go to the next step. As we can see here, we have already all of these enabled. So this is my terminal session. Okay, I'm just revising the data. I think we need to make CLS or to clear the screen anyway, so we will I think we will take this command to display the registry setting for the landman server, and I have already discussed that. We will see that this command is not valid. I'm just putting the name of the server. I think this is not correct. We need to put it in the PowerShell ISE so we can run the command. Anyway, this command is not correct. We need to run it from the PowerShell. Okay, we can see here this is not correct command. So we can get the registry key and put it there. Okay. Okay, we will put it in the IC, but I think here this command is not valid. So anyway, we can see the registry keys. I think we can go further. Okay, just here I'm having another script that I give it any registry key, it will display the setting of the registry key. Okay, so now we have this. Okay, this is the key. I have already tell it to get the content of the key. Okay. So here you go. These are the content of this registry key, the landman server parameters. You can see enable forced log off, it is already there. Okay, here let me show you something, guys. Here what is the logon or logon hours. Let me show you a screenshot. Logon hours Active Directory. So if you go there, if you go to the images, okay, so here this is a very what I was talking about here. This is the thing. You can get it from, I think, the Active Directory users and computers. I think from the user setting. Let's see here how we can do that. This is the login hours. So if you have set it to or I think this is for, okay, this is for the user account. So you can go to the user account and set the login hours time. So if the login hours time are exceeded, then you will be disconnected from the share on the file server, okay, or on the shared folders on the server. Okay, so here we can see these are the login hours. If we go there, Okay, here you go. He's saying the same thing. Security option, disconnect clients when log off hours expire. This is also the one of the recommendations, as we can see here. So this is very simple. You can just right click the user object in the Active Directory and set in the account tab and set the login hours. Okay, so this is what we are talking about, and as we see here, this is how you can disconnect it after the login hours is expired from the group policy. Okay, so this is simply how we can do that. Or from the registry. So I think we can pass this real quickly. Okay, we can go further. So here we go to the next thing, which is MS Legacy, or the next test, which is MS Legacy. What is the MS Legacy? Here he is talking about some of the TCP/IP protocol parameters. You need to tweak a little bit some of the TCP/IP protocol parameters to secure the connection, or to secure the connection with the servers. He's saying here provide or he is giving us some things to we need to disable IP source routing for the TCP/IP parameters, and we need to enable ISMP redirect. Here we need to enable this feature and disable this feature. What is disable IP source routing? What is enable ISMP redirect? We need to know these two parameters. So this registry key, here he is playing with the TCP/IP protocol or service or parameters. Okay, let's see first what is disable IP source routing, what is enable ISMP redirect. If we go to Perplexity and try to see what is, let me first show you here an example. Okay, I think, okay, here you go. What is IP source routing? Here you go. Let's read what is IP source routing and what does it do exactly. Just wait for a moment. And here is saying we should not disable it, okay, give it a certain number. Okay, so here we can see that in the test he's saying that disable IP source routing. Okay, this should not be 0 but should be 2. Okay, the value should be 2, not 0. Here we will see that we need to set it to 2, okay, not to 0. Setting it to 2, it will disable IP source routing. Let's see first what is IP source routing. If we go there and try to read it loudly. Okay, here you go. Let's read it. Okay, and read it loudly.
The Disable IP Source Routing Registry Key is a security setting in Windows that controls the handling of IP source routing, a technique that allows the sender of a packet to specify the route it should take through a network. This capability can pose security risks, particularly in terms of packet spoofing and denial of service (DOS) attacks, where an attacker can obscure their identity and location by manipulating packet routes. Registry Key Details. Registry Path HKE wind machine /system /current control set /services /tpip /parameters. Value name. Disable IP source routing. Value type. Reg_sturdy word. Value options. The Disable IP source routing key can be set to the following values. 0. Source routed packets are allowed. 1. Source routed packets are ignored unless IP forwarding is enabled. 2. Source routing is completely disabled. Reason for setting value to 2. Setting the value of Disable IP source routing to 2 is recommended for enhanced security. This configuration completely disables the processing of source routed packets, thus mitigating risks associated with packet spoofing. By doing so, It prevents attackers from exploiting the source routing feature to send packets that could bypass security measures or obscure their true origin. This setting is particularly important in high-security environments, as it helps to ensure that all incoming source-routed packets are dropped, thereby protecting the network from potential vulnerabilities associated with this feature. Organizations aiming for a robust security posture often implement this setting as part of their server hardening practices to safeguard against various network-based attacks. In summary, configuring the Disable IP Source Routing Key to 2 is a proactive measure to enhance network security by eliminating the risks associated with IP source routing.
So as we can see here, this is an explanation, but we need to put it in an example how this can be implemented by a hacker. Okay, so let's see how this or disable IP source routing is very, very important. Let's see an example here and see how this is implemented and used by hackers. So let's see this example. Okay, and read it loudly.
Here's an example of how an attacker could exploit IP source routing and why setting Disable IP Source Routing to 2 is important. Let's say there is a web server hosted in a company's internal network. The server has a vulnerability that allows remote code execution, RCE, when a specific URL is accessed. An attacker discovers this vulnerability and wants to exploit it. However, the web server is only accessible from the internal network and has strict firewall rules that block all incoming connections from the internet. The attacker cannot directly connect to the vulnerable server. If IP source routing is enabled on the target system, i.e., Disable IP Source Routing is set to 0 or 1, the attacker can craft a malicious packet with a spoofed source IP address that appears to come from inside the internal network. They can also specify a route in the packet header that tells the server to send the response back through the attacker's system. When the vulnerable server processes the malicious packet, it will execute the attacker's code and send the response back to the attacker's system, bypassing the firewall. The attacker can then gain unauthorized access to the server and potentially spread to other systems on the network. By setting Disable IP Source Routing to 2, the server will completely ignore and drop any incoming packets with source routing options, preventing the attacker from exploiting the vulnerability in this manner. This setting helps to mitigate the risks associated with IP source routing and enhances the overall security of the system.
So this is why we need to disable IP source routers. IP source routing. What is enable ISMP redirect? This is another registry key we need to disable. Okay, so I think this is disable, not enable. So these two keys should be disabled. Okay, so why or what is enable ISMP redirect registry key and why should it is be disabled? Let's also read the answer of perplexity, and we will see an example on what will happen if this registry key is enabled, not disabled. So let's go further and see what this will do.
The Enable ICMP Redirect Registry key in Windows controls whether the system accepts and processes ICMP, Internet Control Message Protocol, redirect messages. This setting can be found in the registry at text HKEY local machine /system /current control set /services /tpip /parameters. Functionality of ICMP redirects. ICMP redirects are used by routers to inform hosts about better routes for sending packets. When a router detects that a packet can be sent more efficiently through a different gateway, it sends an ICMP redirect message to the host, suggesting that it should update its routing table accordingly. While this can optimize network traffic, it introduces significant security risks. Reasons to disable Enable ICMP redirect. Disabling ICMP redirects, setting Enable ICMP redirect to 0 or disabled, is recommended for several reasons. Spoofing vulnerability. Attackers can forge ICMP redirect messages to mislead hosts into sending traffic to malicious IP addresses. This can redirect sensitive data or traffic to an attacker-controlled device. Man-in-the-middle attacks. By exploiting ICMP redirects, An attacker can position themselves between a host and its intended destination, allowing them to intercept, modify, or inject malicious traffic. Network disruption. Accepting ICMP redirects can lead to improper routing of packets, potentially causing temporary disruptions in network communication. This can affect the overall stability and reliability of the network. Security best practices. Many security frameworks and guidelines, such as the CS benchmarks, recommend disabling ICMP redirects as part of a comprehensive hardening strategy for network devices and servers. This helps establish a more secure baseline configuration. Conclusion. To ensure a more secure network environment, it is advisable to disable the Enable ICMP Redirect setting in Windows. This action minimizes the risk of routing-related attacks and helps maintain the integrity of network communications.
So let's see an example what will happen if this feature or this registry key is enabled. So first let me read it loudly. Okay, so here we go, and here is an example.
Here's an example illustrating the risks associated with enabling the Enable ICMP Redirect registry key and why it should be disabled. Scenario: man-in-the-middle attack using ICMP redirects. Imagine a corporate network where several employees are connected to a local area network, LAN, with a router that manages traffic to and from the internet. Each employee's computer is configured to use the router as its default gateway. Step-by-step example. Normal operation. Employee A's computer, IP 192.168.1.10, sends data packets to a web server, IP 203.0.113.5, on the internet through the router, IP 192.168.1.1. Attacker setup. An attacker, IP 192.168.1.20, gains access to the same LAN. The attacker can monitor the network traffic and sees that employee A is communicating with the web server. Sending a malicious ICMP redirect. The attacker sends a forged ICMP redirect message to employee A's computer, claiming that the best route to the web server is through the attacker's machine instead of the router. The malicious ICMP message might look something like this. Text. Type. Redirect. Type 5 code. Redirect datagram for the host. Code 0. Gateway address 192.168.1.20, attacker's IP. Employee A's computer updates its routing table. If Enable ICMP Redirect is enabled, set to 1. Employee A's computer accepts the ICMP redirect message and updates its routing table to send packets destined for the web server to the attacker's IP address instead of the router. Intercepting traffic. Now, all of employee A's traffic to the web server is routed through the attacker's computer. The attacker can intercept, read, modify, or even inject malicious content into the data packets. Potential outcomes. The attacker can capture sensitive information, such as login credentials or financial data, or redirect the employee to a phishing site designed to steal further information. Conclusion. This example highlights the security risks associated with enabling ICMP redirects. By disabling the Enable ICMP redirect key, organizations can prevent attackers from exploiting this feature to redirect traffic and potentially execute man-in-the-middle attacks. Disabling this setting is a simple yet effective measure to enhance network security. Share.
So this is why we need to disable these features. Let me show you also one thing here from Claude. Okay, if we go and tell him or see the explanation of Claude, if I go there, let me see that. Here you go. And okay, I think this is it. So this is IP source routing. Oh, okay, so it's disabled. Okay, so I think this is something else. Let's see one thing here. And if we go to TCP IP, just resetting. Okay, so I think this is related to the registry keys 4. So here we can see how we can get so we can uh, disable this 2 from the registry, or using a group policy. I will show you all how we can do that. So let me show you all the screenshots. So if we close this one, if we go like that, okay, and you go like this, so we go to the screenshot. Okay, let's see, this is the MMS. Okay, here you go. This is enable ISMP redirect, and as for the IP router or IP source routing, and this is IP enable route. I think this is it. So this is set to 0. This should be set to 2. If we go there, we can see expected value is 2. I think no, the registry key itself is not there. If we go there, we can see we have only enable ISMP redirect. We don't have disable ISMP or disable IP source routing. So we need to create the key and give it the value, or we create a key, and this key should be reg dword, and we should set it to 2. And if you do not need to bother yourself with that, we can do this through a group policy. I will show you all how we can set the 2 settings for the enable ISMP redirect and disable ISP source routing using a group policy. So I need to see something before going further. I remember that I have already ChatGPT, I have already asked it to explain this before. So let's see if I have already saved the link here. Okay, page not found. Anyway, so let's see how we can disable this 2, not from the registry. So you can do this from the registry by what you need to do to, here it is already set to 1, so we make it 0, and we will create a key and we will name it disable IP source routing, okay, and give it the value of 2. Okay, but let's see how we can do this from the group policy. So we can see from the link of Microsoft, you can get the group policy concerning something called MS Legacy Group Policy. This is a group policy that should be added to the Group Policy Management console, and then you will have the option to disable IP source routing and disable IP source routing and disable the enable ISMP redirect registry key. This will be done in very, very simple terms. Let me show you all how this is done. We go there. So this is the link, MS setting group policy. If you download it, it's not there, the link is not valid. So what we need to do, we need to get it from GitHub. If we go further, let me show you again. Let's go further. Okay. So it's not there. If you try to download it, it's not there. Let me show you all how we can get the group policy, okay, which is called MS Legacy, to control or to disable enable ISMP redirect registry key and disable IP source routing registry key. So if you go there, this is the GitHub. Okay, let me get further like that. So you go to the GitHub event sensory resources, you can get the group policy. Here is the group policy. Okay, this should be added to your group policy management console, and you will be able to control the enable ISMP redirect and disable IP source routing. I need to add this group policy templates, okay, to my group policy central store location. Now you need to unzip the file. But I need to give a little bit of a note here. If you disable this too, you should monitor your network operation, because maybe disabling something like that may affect your network. But in real world scenarios, I think this will not affect, but you should also monitor it, because this is related to TCP IP protocol parameters. So this is very critical thing to play with. Okay, so let's see how we can add these two, or add this setting, or adding this group policy templates. We will copy it and put it in the shared folder between my virtual machine and my host, or my guest and my host. So now I need to go to my primary domain controller. Okay, now we open the shared folder, okay, and get the unzipped folder called resource main, copy, and put these group policy templates in my group policy central store location. So I need to get to the group policy central store location, which is in my sysvol folder. Here you go. Then we go to the policies, and then we go to the policy definitions. And then here are the group policy templates. Okay, we need to copy the ADMX files, this one and this one. We need to put it in the group policy central store location. Here is the policy definitions. We will paste them there, and we will put the ADML files in the ENUS folder, because this group policy, it is in English language. So we need to put the ADML files in the folder of English United States. Here we can get this too. If this is in different language, you will see a folder for the language in the policy definitions. So this will control the language that the group policy will appear in. Okay, so now if you open, or maybe first we need to make a refresh, and then we can go to the default domain policy, okay, and then right click and edit, and go to administrative templates, not Windows setting. If you go further, okay, administrative templates, just wait for a moment. Okay, here you go again. So we can go to the administrative templates, just wait for a moment. Okay, here is administrative templates. Then we can go to MSS legacy. Here we can see that we have disable IP source routing version 6 and IP source routing version 4. So these are the two. Okay, you can play with the registry from this group policy, and this enable ISMP redirect. Okay, so now you can play with all of these registry keys using this group policy. And as we can see here, all of these are about maybe 20 or more registry keys that you can use to play with different configuration in the Windows. Okay, some of them are related to TCP IP, some of them are related to for example, file system, which we will talk about now, something called file or NTFS file naming system. Okay, we will see that in a moment. But anyway, this group policy is very useful. Okay. So let me show you the link. If we go there, this is Microsoft. If we go to these or to this link, here you go, we can see that it says contain about 20 registry values. Okay, that if tweaked, it will do a security gain. Okay, so these are all 20 registry keys that playing with them will enhance your security. Okay, some of these keys are related to the TCP IP parameters, okay, and others are related to other things. Anyway, so you can read in this, okay, and what are these things, and anyway, so you can read it in details. So if we go and go to the next test, or go to the next finding, we go to something called file system. If you go down, okay, something called get down. Okay, so just a moment. So the next thing is something called file system. It makes sure that your file system is NTFS, and you need to see if the option called NTFS disable 8.3 name creation, this should have a certain value. What is NTFS disable 8.3 naming creation? Let's see that. So this is related to the NTFS uh, uh, setting and some of the NTFS settings. So let's see what is this thing. If you go there and talk about, just wait for a moment. Okay, so what is disable 8.3 name creation? But first, let's see the answer here first. This is the registry key, okay, and it is talking about this registry key. Okay, let's see first the answer of perplexity. First, let me show you all the screenshot for it. I think we can go there, and here is the matrix lab. Where is the NT? We can find it here. NT session, NTDS, I don't think so. Okay, this is not it. Anyway, so let's read the answer. So this is the test. Okay, if we go further down, okay, this is the file system. It should be, if we see the registry key here, he's checking the registry key. We need to make sure that we have NTFS and we have this feature to be a value greater than 0. What is this feature exactly? Let's see, or let's read it.
The HKLM /system /current control set /control /file system registry key in Windows contains various settings that control the behavior of the file system and its features. Here are some key aspects of this registry key. Key subkeys and values. Disable delete notification. Controls whether the system will notify applications about delete operations. Long paths enabled. When set to 1, this allows the use of file paths longer than the traditional 260 characters, which is especially useful for applications that require deep directory structures. NTFS disable 8.3 name creation. If set to 1, this disables the creation of 8.3 short names for files, which can improve performance on NTFS volumes. NTFS disable compression controls whether NTFS compression is allowed. Setting this to 1 disables compression. NTFS disable encryption prevents the use of file encryption on NTFS volumes when set to 1. NTFS allow extended character in 8.3 name. Allows the use of extended characters in 8.3 file names if set to 1. NTFS encrypt paging file. When enabled, this setting encrypts the paging file for added security. Importance of the file system registry key. The settings within the file system registry key are crucial for optimizing system performance, enhancing security, and ensuring compatibility with various applications. For example, enabling long paths can significantly benefit applications that handle large volumes of files or complex directory structures, while disabling 8.3 name creation can improve performance on NTFS volumes. Example use case. For organizations that need to manage large data sets or complex applications, adjusting the long paths enabled value to 1 can prevent errors related to file path length limitations. Similarly, disabling short name creation can lead to better performance in environments where legacy applications are not in use. In summary, the HKLM /system/current control set /control/ file system registry key is essential for configuring file system behavior in Windows, impacting both performance and security. Adjusting these settings should be done with consideration of the specific needs of the environment and applications in use. Share. Rewrite. What if NTFS disable 8.3 name creation set to 2? Sources: MSFN. 1. 7 forums. 2. Disable long file names to improve Windows performance. Bucaro Techulp. 3. View 2 more. Answer: NTFS disable 8.3 name creation set to 2. When the NTFS disable 8.3 name creation registry value is set to 2, it means that the creation of 8.3 file name aliases is controlled at the volume level. This is the default setting in some versions of Windows, such as Windows 7. What does setting 2 mean? 0. 8.3 file name creation is enabled. 1. 8.3 file name creation is disabled. 2. 8.3 file name creation is controlled by the file system, which may enable or disable it based on various factors. With NTFS disable 8.3 name creation set to 2, the file system will determine whether to create 8.3 file name aliases based on the specific volume and its configuration. This allows for more granular control compared to a global enable/disable setting. Potential impacts. Performance. Disabling 8.3 name creation, setting to 1, can improve performance on NTFS volumes by reducing the overhead associated with maintaining the additional file names. Compatibility. Some older applications may rely on the existence of 8.3 file names, so disabling them entirely could cause compatibility issues. Security. Leaving 8.3 name creation enabled can potentially expose security vulnerabilities, such as the tilde directory enumeration issue in IIS, where an attacker could use the 8.3 name to disclose file and folder names. In summary, setting NTFS disable 8.3 name creation to 2 allows the file system to manage 8.3 name creation based on volume-specific factors. For optimal performance and security, it's generally recommended to disable 8.3 name creation entirely. NTFS disable 8.3 name creation equals 1, unless there are specific compatibility concerns with older applications.
So this is the feature. So here is checking if you have the NTFS disable 8.3 net name creation is set to value greater than 0. Here I have it set to 2. What is this feature? This feature is shortcutting the file names or the long file names of files to smaller names, because some application doesn't support the files or reading the files with long characters, for example. So this is some legacy applications doesn't know how to read files with long names. But today, most of the new applications or uh, uh, most of the new applications can read long files. This was for the old or legacy programs. Okay, if we go to Perplexity, let me see, because I think I have a lot of things here still. Still we can read from it. Just wait for a moment. So let's see here something. Okay, so let's go further. Mm, so okay, here with what is NTFS disable 8.NET 3 name creation. Here he is giving you a simple explanation about it. This is let me. Okay, when 8.3 name creation is enabled, NTFS generates a short format name alias, for example, document so and so, in addition to the long file name or compatibility with older application that not support long file names. So this is shorten the file name. It is more, if the file name is more than 9 characters or 8 characters, it will shorten, cut it to 8 characters or 8.3, I think. Anyway, so this is something or a couple of things. Let me, before going further, I will go a little bit back to something here. Let me, if I go further, sorry guys, I will go a little bit further. Okay, so this is the file system. Here we have already this set to 2, but I need to go further to discuss a little thing here concerning the MS legacy. A couple of things here, or a couple of things concerning the IP source routing and ISMP redirect. Couple of questions that should be very, very clear. Who is responsible for choosing the best route for data packets? If we know that we have disabled IP source routing, so who is responsible for routing the packets? Okay, if we disable this from the client side or from the server side, so who will be responsible for routing the packets? Okay, if we go there, let me see the answer here, or let me show you the answer.
The responsibility for choosing the best route for data packets primarily falls to routers within a network. Routers are specialized networking devices that connect different networks and determine the most efficient paths for data transmission based on various criteria. How routers determine the best route. Routing tables. Routers maintain routing tables that contain information about various network destinations and the paths to reach them. These tables are essential for making informed routing decisions. Routing protocols. Routers utilize routing protocols, such as RIP, OSPF, or BGP, to dynamically learn about network topology changes and update their routing tables accordingly. These protocols help routers communicate with each other to share information about available routes. Factors considered. When determining the best route, routers consider several factors, including distance, the number of hops, intermediate devices, to the destination. Latency, the time it takes for data to travel along a path. Network congestion, the current load on the network, which can affect performance. Cost metrics, some routing protocols use cost metrics to evaluate the efficiency of a route. Forwarding decisions, once a router determines the best path for a data packet, it forwards the packet to the next hop on that path, ensuring it progresses toward its destination. Conclusion. In summary, routers are responsible for selecting the best route for data packets by utilizing routing tables and protocols, considering various factors such as distance and network conditions to optimize data transmission across networks. Share. Rewrite. Does setting disable IP source routing registry key to 2 and enable ICMP redirect to 0 have any effect on the router's routing process? Sources: GPO registry key, disable IP source routing value. Community.spiceworks. 1. MSS, disable IP source routing, IP source routing protection level, ADNCS. 2. 1.1.1.2.1.56 set, MSS, disable IP source routing, IP, tenable. 3. View 2 more. Answer: setting the disable IP source routing registry key to 2 and the enable ICMP redirect registry key to 0 primarily affects the behavior of the local Windows system regarding packet handling and security, but does not directly influence the routing process of routers in the network. Effects of the registry settings. Disable IP source routing equals 2. This setting disables all incoming source routed packets. When set to 2, any packets that attempt to specify their route through the use of source routing will be dropped. This is a security measure to protect against packet spoofing and related attacks, as it prevents attackers from manipulating the routing of packets to obscure their origin or bypass security measures. Enable ICMP redirect equals 0. Setting this to 0 means that the system will not accept ICMP redirect messages. ICMP redirects are used by routers to inform hosts about better routes for sending packets. By disabling this feature, the local system will ignore any suggestions from routers to change its routing behavior, ensuring that it only uses the routes defined in its own routing table. Impact on router routing process. Local versus router behavior. The settings primarily affect how the local machine processes incoming packets and responds to routing suggestions. They do not change how routers make routing decisions or how they handle packets. Routers will continue to route packets based on their own routing tables and protocols, like OSPF, BGP, etc., independent of the settings on a local machine. Security enhancements. While these settings enhance the security posture of the local machine by preventing certain types of attacks, they do not influence the overall routing efficiency or decisions made by routers in the network. Instead, they ensure that the local system does not accept potentially malicious packets or routing suggestions that could compromise its security. Conclusion. In summary, setting disable IP source routing to 2 and enable ICMP redirect to 0 improves the security of the local Windows system by controlling how it handles source-routed packets and ICMP redirects. However, these settings do not directly affect the routing process of routers, which continue to operate based on their own configurations and protocols. Share. Rewrite. What if the router needs to inform the PC about an alternative route to and the enable ICMP redirect what disabled? How this is done? Sources. MSS. Disable IP source routing IPv6, IP source routing protection level. GitHub. 1. How to configure an intranet router to inform its hosts about routes to superuser. 2. What is Routing Information Protocol, RIP, and how does it work? TechTarget. 3. View 2 more. Answer. If the router needs to inform the PC about an alternative route, but the Enable ICMP Redirect setting is disabled, set to 0, the router will not be able to use ICMP redirect messages to notify the PC. In this case, the router has a few options to provide the PC with updated routing information. Using DHCP to provide routing information. The router can include routing information in the DHCP options when assigning an IP address to the PC. This allows the router to push the necessary routing information to the PC during the DHCP lease acquisition process. For example, in OpenWRT, you can add the following DHCP options to configure the PC's routing table. Text. Option classless static route 192.168.144.0/24, 192.168.7.94, option MS classless static route 192.168.144.0/24, 192.168.7.94. These options will instruct the PC to add a static route for the 192.168.144.0/24 network with the next hop IP address 192.168.7.94, the router's interface connected to the other network. Configuring static routes on the PC. If DHCP is not an option, the router can provide the necessary routing information to the PC administrator, who can then manually configure static routes on the PC. This ensures that the PC knows how to reach the desired network through the router's interface. For example, on the PC, the administrator can add the following static route. Text. Route add net 192.168.144.0/24 GW192.168.7.1. This command adds a static route for the 192.168.144.0/24 network with the gateway IP address 192.168.7.1, the router's interface connected to the PC's network. Using dynamic routing protocols. If both the router and the PC support dynamic routing protocols like RIP, Routing Information Protocol, the router can use these protocols to advertise the available routes to the PC. The PC will then learn the routes from the router and update its routing table accordingly. However, it's important to note that dynamic routing protocols may not be supported on all PCs or may require additional configuration. In summary, when Enable ICMP redirect is disabled, the router can use DHCP options, static route configuration, or dynamic routing protocols to inform the PC about alternative routes, ensuring that the PC can reach the desired networks through the router's interfaces. Share. Rewrite. What is NTFS Disable 8.3?
So as we can see here, disabling the enable ISMP redirect will not affect the routing of the packets, and the same for disable IP source routing. So the only one responsible for choosing the route and defining this route is the router, not the client. So the client does not say or does not choose what is the route for the data packet. The one responsible for this is the router. So disabling it on the client side will not affect the routing operation. As for enable ISMP redirect, as you can see here, there is a lot of ways the router can tell the PC about alternative paths to route the packets to. So we can see this will not affect anything, because this too should not be done by the client. This should be done by the router. The source routing or IP source routing and the redirect of the packets, this should be done from the router side, not from the client or server side. So this is one thing I forgot to mention. Okay, so we have seen the file system. As we see, this is the option. We can disable it to disable the shorten of the long file names in our operating system. This can enhance the performance, but if some old programs use short file names for their operation, it will affect these programs. But anyway, we have it. 2 is the best option, to leave it for the volume or leave it for the system to choose whether to disable or enable, and this is also accepted. Okay, so we can go to the next thing, with its net session enumeration. This is the method used to retrieve information about established sessions on a server. Okay, any domain user can query a server for its established sessions. So here, this is an option we should make sure it is not enabled, because any user can ask the server about the sessions that are established to it, and a hacker can use this option very wisely. So here is the test. It will make sure that authenticated users are not able to query the servers for the sessions that are established to it. Okay, if we go to let me show you. If you go to Perplexity, let me go further because I have it already also explained by Perplexity. If we go further here, if we go up, let's go further. I think here we can go, okay, we can go further. I think, let's see here. Okay, if we go, okay, I think here this is also, this can be, we can get this setting or disable this setting from this registry key. So here I'm asking it to explain this registry key. Okay, so let's see the answer of perplexity, but this is not the thing here I'm talking to. What is this registry key? Okay, no, this is not the thing I need. Just wait for a moment. Okay, I think, okay. So here basically we need to make sure that, let me get you something here. There is a key called server session info. Okay, this key, let me show you the registry key itself. Okay, here is the NTS session. Okay, this should not be given to the authenticated users. If this key is bind to the authenticated users, then the users can query the server for the sessions on it. Let me see if this is already explained here in this. Okay, I think he's explaining this one. Let me see here. Okay, this key. Okay, let's explain it. Okay, let me read it loudly. Just wait for a moment. Okay, here you go. Let's read it loudly.
Answer. The SRV-SVC session info registry key, located under HKLM /system/current control set/services/LAMN server/default security, is used to manage security descriptors related to file and print server sessions in Windows. This key plays a critical role in defining who can access and manage sessions on the server. Key functions of SRV-SVC session info. Security descriptor. The SRV-SVC session info key contains a security descriptor that specifies the access control list, ACL, for session enumeration and management. This includes permissions for users and groups to view and manage active sessions on the server. Session management. By controlling access to session information, this key helps prevent unauthorized users from discovering which accounts are logged into the server. This is particularly important for mitigating internal reconnaissance attacks, where an attacker might seek to identify active sessions to exploit. Default permissions. The default value of this key dictates the permissions assigned to users and groups regarding session management. Modifying this key can enhance security by restricting access to session information. Example of use. For instance, if an organization wants to enhance its security posture against internal threats, it can modify the SRV-SVC session info key to limit access to session information. By doing so, only administrators or specific user groups would be able to enumerate active sessions, making it harder for potential attackers to gather information about logged-in users. Conclusion. The SRV-SVC session info registry key is essential for managing the security of file and print server sessions in Windows. Properly configuring this key is crucial for protecting sensitive session information and improving overall network security. Share, rewrite, view more.
So, sorry guys, here we need to make sure that this registry key, the authenticated users doesn't have access to this key, because if they have access to this key, they can see the sessions on the server and read who is currently accessing the server. So here, what we need to see here, this test enumeration enumeration, session enumeration, is making sure that this key, which is the server session info, the authenticated users doesn't have read permissions or have permissions on this key, because if they have, then what they can do, they can retrieve here, if they have access to this key, they can retrieve information about established sessions on a server. Okay, so we need to make sure any domain users can query a server for established sessions, so we should make sure that this key, the authenticated users doesn't have access to this key. This is very, very important, guys. Okay, so we have seen that we have already this, we have passed it, so we'll stop at this for a moment. So let's continue, guys. Here we have this test, which is concerning the WinRM. We know that the WinRM, it is a service used to remotely access servers and workstations and apply to them PowerShell commands or CMD commands. So this is the service of WinRM is responsible for this. So there is a feature that you can store your administrative credentials within the Windows Remote Management Service. So this is not a good, or this is not a best practice. You need to disable storage of administrative credentials through the Windows Remote Management Service. So this feature is called Disable Run As. This is a service we can disable it from the registry key, or I think you can do it also from the group policy. Here you can see storage of administrative credentials could allow unauthorized access, disallow the storage of run as credentials for Windows Remote Management. Will prevent them from being used with plugins. Okay, this is the service. You can disable it from the registry. Okay, something called disable run as. This should be one, or you can do it from the Windows components, administrative templates, disallow WinRM from storing run as credentials. So this is basically what is or what we should do with the WinRM. Okay, here we can see here I'm asking it to explain the registry key, or let me, I think I have a screenshot of the WinRM. If I go to there and see maybe W, maybe. Okay, I don't have a screenshot for this one. So let's go anyway. So let's go and see why disable run as registry key under so and so, why we should disable this key. Okay, let's see why is that perplexity have asked, or it have answered this by giving us this answer. Let's see what is the answer. Okay, let's go there and see that, or read it loudly.
The disable run as registry key under HKY_local_machine /software /policies /Microsoft /Windows /WinRM /service should be set to 1, enabled, to prevent the Windows Remote Management WinRM service from storing run as credentials. This is an important security measure to mitigate the risk of unauthorized access. Reasons to enable disable run as: preventing storage of administrative credentials. When the disable run as key is disabled, set to 0, the WinRM service can store administrative credentials. This poses a security risk, as it allows these credentials to potentially be used by unauthorized parties or malware. Mitigating unauthorized access. Enabling disable run as, setting it to 1, disallows the storage of run as credentials, reducing the attack surface and preventing unauthorized access to the system. Aligning with security best practices. Many security frameworks and guidelines, such as the Security Technical Implementation Guide, STIG, recommend enabling the disable run as setting as part of secure configuration practices for Windows systems. Example configuration. To enable the disable run as setting, open the registry editor, regedit.exe. Navigate to the key path, hkey_machine/software/policies/Microsoft/Windows/WinRM/service. If the disable run as value does not exist, create a new DWORD 32-bit value with the name disable run as. Double-click the disable run as value and set its data to 1, enabled. By enabling the disable run as setting, you can enhance the security of your Windows systems by preventing the WinRM service from storing sensitive administrative credentials, reducing the risk of unauthorized access and potential data breaches.
So we can see here that we don't have this enabled. We will see how we can do this through a registry or through a group policy. We'll see all of this through the video. I'm just discussing the results of the test, and then we will see how we can rectify all of these findings practically. So this is another test, and then we can go to the next one, which is hardening UNC passes, okay, or unique network. I think this is something, or I will see what is the UNC must be defined to require mutual authentication integrity, at least for sysvol and netlogin. This is to secure the accessing to the shared folder sysvol and netlogin, something called hardening UNC passes. We are securing the connection of the clients to the sysvol folder and netlogin share. This will be done using also a group policy or through a registry key. So here we go. If you need to secure the connection to the sysvol shared folder and netlogin shared folder, we need to do something called the hardening UNC or universal naming convention. Okay, so what is a universal naming convention? If I put the name of the PC, for example, then slash the share folder name, okay, this is called as a whole, it is called UNC, or this is as a whole is called universal naming convention. So we need to secure the access to this universal naming convention, especially to the sysvol folder and the netlogin folder. Okay, we will do this through a registry key. Okay, so we can do this from a registry key. This is done through software, local machine software policies, Microsoft Windows network provider, hardening paths, and then we need to do this too. Accessing the netlogin share require mutual authentication and require integrity. The same for the sysvol. Okay, so this can be done using the registry or through a group policy. This can be done for the computer configuration, administrative templates, network provider, hardening UNC passes. Okay, so we can do both. Okay, let's see what is hardening UNC passes. Okay, this is the definition of hardening UNC passes, and let's see what is the answer of perplexity.
Hardened UNC paths are a security feature in Windows that enhance the security of accessing network resources via Universal Naming Convention, UNC, paths. This feature is particularly relevant for domain-joined systems and is configured through group policy. Overview of hardened UNC paths. Purpose. Hardened UNC paths enforce additional security requirements for accessing specified UNC paths, such as those used for network shares. This helps protect against vulnerabilities that could allow unauthorized access or data tampering. Configuration. When the hardened UNC paths policy is enabled, Windows requires that specific security measures be met before allowing access to the defined UNC paths. These measures include mutual authentication. Ensures that both the client and server authenticate each other to prevent man-in-the-middle attacks. Integrity. Guarantees that data sent between the client and server is not tampered with during transmission. Privacy. Optional. Ensures that communications are encrypted to protect sensitive data from eavesdropping. Key features. Policy path. The hardened UNC path setting can be found in Group Policy under Computer Configuration, Registry Settings. The corresponding registry entries are located at HKEY machine /software /policies Microsoft Windows network provider hardened paths. Configuration example. To secure access to critical shares such as Netlogon and Sysful, the following configurations are typically recommended. Value name / *Netlogon. Value. Require mutual authentication equals 1. Require integrity equals 1. Value name / *Sysful. Value. Require mutual authentication equals 1. Require integrity equals 1. Importance of hardened UNC paths. Mitigating vulnerabilities. By enforcing these security requirements, hardened UNC paths help protect against various attack vectors, including spoofing and unauthorized access, which can exploit weaknesses in UNC path configurations. Best practices. Organizations are encouraged to enable this policy, especially for paths that host executable programs or sensitive files, to ensure that only authenticated and authorized users can access critical resources. Compliance. Enabling hardened UNC paths is often part of compliance with security standards and frameworks, such as those outlined in Security Technical Implementation Guides, STIGs. In summary, hardened UNC paths provide a robust mechanism for securing network resource access in Windows environments by enforcing mutual authentication and data integrity, thereby reducing the risk of unauthorized access and data breaches. Share. Rewrite. Give me an example. Answer. Certainly. Here's an example of how to configure hardened UNC paths in a Windows environment to enhance security for accessing network shares. Example scenario. Objective. Secure access to the Netlogon and Sysful shares on a domain controller to ensure that only authenticated and authorized users can access these critical resources. Steps to configure hardened UNC paths. Step 1. Open Group Policy Management. Press Windows + R to open the Run dialog. Type gpmc.msc and press Enter to open the Group Policy Management console. Step 2. Create or edit a Group Policy Object, GPO. In the Group Policy Management console, navigate to the Domain or Organizational Unit, OU, where you want to apply the policy. Right-click on the domain or OU and select Create a GPO in this domain and link it here, or choose an existing GPO to edit. Name the new GPO, e.g., Hardened UNC Paths Policy, and click OK. Step 3. Edit the GPO. Right-click on the newly created or existing GPO and select Edit. In the Group Policy Management Editor, navigate to Text. Computer Configuration. Step 4. Configure hardened UNC paths. Look for the Hardened UNC Paths setting. Double-click on Hardened UNC Paths to open its properties. Click on Enabled. In the Hardened UNC Paths box, you will need to add the paths and their corresponding security requirements. Example configuration. Add the following entries. Value name / *Netlogon. Value. Require mutual authentication equals 1. Require integrity equals 1. Value name / *Sysful. Value. Require mutual authentication equals 1. Require integrity equals 1. Step 5. Apply and close. Click OK to save the settings. Close the Group Policy Management Editor. Step 6. Update group policy on clients. To apply the new policy settings, you can force a group policy update on client machines by running the following command in the command prompt. Bash update/force. Result. By configuring hardened UNC paths for Netlogon and Sysful, you ensure that mutual authentication. Both the client and server must authenticate each other before allowing access to these shares. Data integrity. Any data transferred between the client and server is protected from tampering. Conclusion. This example illustrates how to implement hardened UNC paths in a Windows environment to secure critical network shares. By requiring mutual authentication and integrity checks, Organizations can significantly enhance their security posture and protect sensitive resources from unauthorized access and attacks.
So here I think I'm asking it, give an example of an attacker taking advantage of not using hardened UNC. This is a very, very important question. Let's see the answer.
Attacks. Share. Rewrite. Give an example of attacker taking advantage of not using hardened UNC paths. Sources. Hardened UNC paths. ADNX.help. ADNX. 1. Hardened UNC paths must require mutual authentication. Event Sentry. Event Sentry. 2. Hardened UNC paths must be defined to require mutual authentication. StigViewer. 3. View 2 more. Answer. Here's an example of how an attacker could exploit the absence of hardened UNC paths in a Windows environment. Scenario: exploiting UNC path vulnerabilities. Objective: an attacker aims to gain unauthorized access to sensitive files on a network share by leveraging the lack of hardened UNC paths. Step-by-step example. Network setup. A company has a network share accessible via a UNC path, such as / fileserver / confidential. This share contains sensitive documents, including financial reports and employee data. Lack of hardened UNC paths. The organization has not configured hardened UNC paths, meaning that the network share does not require mutual authentication or integrity checks. As a result, the share is vulnerable to various attacks. Attacker reconnaissance. The attacker, who has gained access to the internal network, perhaps through phishing or exploiting another vulnerability, performs reconnaissance to identify accessible UNC paths. They discover the / fileserver / confidential share. Spoofing the server. Without hardened UNC paths, the attacker can spoof the file server's identity. They set up a rogue server that mimics the legitimate file server. Because mutual authentication is not enforced, the attacker's server can respond to requests from clients without being verified. Data interception and manipulation. The attacker sends a crafted UNC path request to the victim's machine, tricking it into connecting to the rogue server instead of the legitimate file server. Since the connection lacks integrity checks, the attacker can intercept sensitive data being transmitted between the client and the server. Unauthorized access. The attacker now has the ability to view sensitive files stored on the share, modify documents, potentially altering financial reports or employee records, delete files, causing data loss or disruption. Exploitation of credentials. If the attacker can capture the credentials of users accessing the share, they can use these credentials to gain further access to other resources in the network. Conclusion. This example illustrates how the absence of hardened UNC paths can lead to severe security vulnerabilities. By not enforcing mutual authentication and integrity checks, organizations expose themselves to risks such as data interception, unauthorized access, and potential data manipulation. Implementing hardened UNC paths is crucial for protecting sensitive network resources and ensuring that only authenticated and authorized users can access critical data.
So this is why we need to use or to harden our UNC passes. This is the test. If we go and continue, the last test concerning our primary domain controller is DC DNS forwards. We need to test if we have our domain controller DNS or the DNS on the domain controller have DNS forwards to resolve websites and servers from outside our network. As we can see here, he already see that we have the gateway as our DNS forward because our gateway has already DNS in it, and we have Google as a DNS forward. We can see it is already there and it is successfully implemented. So we can see all of these tests today. We have seen all of them and discussed them practically or theoretically one by one. Let's see how they are implemented in a practical way. So here we have stopped at, let me stop here at the file system. So we have our legacy already done. We can see how we can begin working with the file system, which is NTFS disable 8.3 net name creation. Let's see one by one being implemented. I think we can pass this really quickly. So here there is a registry key that will check for the NTFS or the file system configuration. If we go there, here is the registry key. This is a simple script to display any registry key content. So here it is. This is the file system registry key. As you can see here that we have already our uh, NTFS disable 8.3.NET naming. It is set to 2. Okay. So here I think we don't need to, I'm asking the AI tools to explain the content of the registry key, but anyway, you have already seen this before. We can continue working. Okay, let's go to the other test, okay, after file system, which is the net session enumeration. Okay, we have seen this, not to let any or authenticated users to query any server for the sessions that are established with this server. Okay, so let's see if we can do anything here concerning this. So we are taking this script to make sure that we have not our authenticated users having the ability to check or to query for the sessions established for shared folders on a server. Okay, this is, we can copy this and put it and see if we can get any result. So we can go there. Here I are checking this registry key. Through it, we need to check for the server session info key. If the authenticated users have read permission to the server session info, if this is there, then any authenticated users can see the sessions that are done to a server. So here I need to know if the server session info, the authenticated users, if you can see here, need to know if this key authenticated users have access to it. If they have access to it, then they can get any session info that are created on the server or established to the server. So we need to make sure how we can translate this data from this key. Actually, I have asked the AI tools to get me or to create for me a script to get me the or to let me know if this key the authenticated users have access to it, because here I can't translate, or the registry key itself I cannot understand the info displayed there. Okay, so let's see how we can do that. So I think I can go to the AI tool. So here I am taking this and asking the AI tool to create, I need a script to get net session enumeration, okay, on the server. Okay, so on my domain controller. So let's see if it will get me a key. And here I am telling it to make sure this is not granted for authenticated users group, just to make sure he will give me, or the script will make sure authenticated users don't have access to the key of server info. Just let me go all of this, and I think no. Anyway, I think I didn't succeed in doing that, but okay, let me see. This is DeepSeek. So here, after trials, here is the script that will do that. Anyway, you can use testmo report to get the result, but this is a way that you can get uh, the same result but using AI tools. Okay, and DeepSeek is one of the good AI tools to create scripts, by the way. So we can continue, and now we can go to the service WinRM. Here I will show you how we can disable this from the group policy. If we go further, here you go, we'll go to the default domain policy and then disable the run as credentials, okay, through the WinRM. Okay, here you go, we can disable WinRM from storing run as credentials. Okay, so we can go to Windows Components, then Windows Remote Management, then to the service, Windows Service, not the client, WinRM service. Okay, and disallow, we go disallow, where you go, disallow, not this one, I disallow WinRM from storing run as credentials. Then you can enable it. So this is it. And then harden UNC pass, we can enable it through a group policy or through the registry key. Let's see how we can do that. Very, very simple. First, I'm here displaying the registry key for the harden UNC pass. Okay, but anyway, you can do this also through a group policy. Okay, let's go further. Anyway, so when checking the registry key, we can do this through a group policy. So here you go, the group policy, we can go and we can do this through a registry key. You can add it manually or through a group policy, which is easier to enable this. Okay, harden UNC pass. Okay, and then administrative templates. Then I think Windows components maybe. Okay, administrative template network provider. Okay, and then harden UNC. Then tell him enable. Okay, and then you can tell him enable and then show. Okay, you put here the value, which is the UNC path, and then you put here require mutual authentication equal 1, integrity equal 1. Here is the path and there is the security setting. Okay, so here is the value name. Okay, and here is the value name and here is the value. So this is simply how you can secure the access to the sysvol and netlogin folder, shared folders. So this is it, and to the last test, which is DNS forwards, you can take this script to test if the DNS forwards are working or on your DNS on your primary domain controller. So you can copy this and put it in our PowerShell ISE. Okay, I will copy this and put it there, and there it will resolve. First we need to do a couple of things. We need to put the forest name, the domain controller. All of these settings should be filled, and then he will resolve a certain website on the internet. If he succeeds in getting the IP address, then we have DNS forwards set up correctly. Okay, you can see here that this command also is not correct. So I asked DeepSeeker to test our DNS forwards. This is here. If we copy that and ask DeepSeek here, the zip coder exactly, I need a PowerShell script to get my DC DNS forwards and then send. Here will give me a script, very simple, get DNS forwards. If this succeed, then also it can be formatted on a table, or it can be formatted in a table, and this can be done remotely as well. Okay, so this can be done locally or remotely. So what we need to do, we need to get DNS forwards to get our configured DNS forwards on our server copied. Then we can go and do that, very simple, like this one, and press enter. We can see we have already the same result. We have already this enable reordering. We have these two set as our DNS forwards. So very simple and very easy. Okay, so this concludes for our video. Now we will stop, or we will close all our servers, and by this one we have already finished all of the findings of the Testomo report concerning our primary domain controller. The same findings are on our additional domain controller. So by this we have finished the Testomo report in general, okay, with all of the findings in the forest domains and domain controllers. In the upcoming video we'll talk about a very important topic, which is Purple Knight Active Directory Security Assessment Tool. This is a very important Active Directory Security Assessment Tool. So until the upcoming video, hope the video informed to you all, and thank you all for viewing. Thank you so much.